Hello, Namaste. This is Rohini Mirgu talking about univariate analysis using R part 2. Part 1 is already shared with you, and this is the part 2 wherein we'll be talking about the univariate visualization part. Learning outcomes. At the end of the video, you will be able to compute univariate frequencies and statistics using R commander. Create visualizations for exploring the single variable using R commander. All univariate analysis that we have seen in the part 1 of this video. Univariate analysis. So different analysis that we have seen is the univariate frequencies, statistics and univariate visualization. We have seen execution of univariate frequencies in the R for finding out the absolute frequency. Table is the function used. Relative frequency, we have used the percentage equations. For cumulative frequencies, we have used COMSUM function. Univariate statistics also been found out by using min function, max function, mean function. Then quartiles have been found out by using the quantile function. We'll see univariate visualizations in the R commander as well as statistics in the R commander. What is R commander? R commander is a graphical user interface, GUI, whereas R studio is IDE, and here R commander is a GUI, which is graphical user interface for R statistical computing environment. R commander provides a point and click interface for performing the common statistical analysis and generating the plots. R commander simplifies the process of R. It still relies on the R behind the scenes. That means internally the same codes are executed that we are writing in R studio, and R commander directly providing you the point and click interface so that it is user friendly and it is a graphical user interface. To open the R commander, we need to type library into the bracket into double inverted quotes R commander, that is RCMDR. Then the R commander will be opened, and in the R commander we can execute, we can see the statistics, univariate statistics as well as the univariate visualizations. You can see univariate, bivariate and multivariate also, but as this video is restricted for univariate, we'll see univariate statistics and univariate visualizations in the R commander. Let us open R. So once R is open, now I can type here library into inverted quotes R commander, that is CMDR, inverted quotes complete and bracket complete. When I press enter, it shows me the cursor shows busy because it is opening the commander window. This is R commander window. In the commander window, it is saying that there is no active data set. But in order to load the data set, I must take one data set, maybe like the same data set which I have used in the part 1, that I can use here. I can type here D read CSV. I can read the CSV file or the Excel file, whichever file in which our data is there, that I can read here, as it is a CSV file, header true and separated by a comma, because in CSV file the attributes values are separated by the commas. Now if I go to R commander, if I see here the data set is been shown D. Why? Because D I have read here, the data set is loaded. Now I can take this data set and I can say OK. Once data set is available, I can see the data set. Yes, I can see it. Here you can see the data set contains the different attributes like friend, temperature, weight, height, then it represents gender and company. So all total 6 attributes, with these as a quantitative, other are the qualitative attributes. Now further I can find out the statistics of this data set. We have done this using the R programming in R studio, like summary that we have done. The same I can do here by clicking on the statistics summaries of the active data set. So it will give the same result, summary of D. So internally it is executing the command summary. But in summaries, again, you can go for frequency distributions that we have done. The frequency distribution of the company, if you see how many people says the company is good, how many people says bad. So it's a 50-50% that you can get. In the statistics, again, you can see the correlation, covariance, all this comes in the bivariate. Numerical summaries, you can find out, like for height attribute, the summary is mean is the standard deviation, interquartile range, its quartiles. So total data samples are 14. So the complete summary has been given if I click on the summaries and I say numerical summaries for whichever attributes we want. Also, we can do visualizations in the R commander. We can see the visualization for the different attributes. Like if I see index plot, I can see the index plot for the height attribute. When I click on OK, I get here height attribute, which is shown here in the R window, whereas this is my commander window. So R window, in the R window, I can see this, and this is my commander window. Here you can see this is the different values of the height. So here height may be 172 and 195 or so. So total 14 samples. As there are 14 samples, all these samples, the height value has been shown. If we want to check, we can check here by we can see this height is 175 at the start. The second sample height attribute is 195. So this is third sample's height attribute is 172. You can get the dot plot for the height attribute. If I see, this is the dot plot. Instead of the lines, it's been shown with the dots. So at 162 there is one dot, at 175 maybe, and so on up to 197 or 95. It is the values have been plotted in the dot graph. Then I can also draw the histogram. Histogram maybe for weight attribute. If I plot, you can see this is my histogram, and if I want to view the data and want to compare how the histogram is plotted, you can see here, like I have plotted for weight attribute, you can see here weight versus frequency is plotted. So if you check the weight between 50 to 60, so here is the weight attribute, this is the weight attribute. So between 50 to 60 only one data sample is there, and between 60 to 70 there are 4 data samples, 70 to 80 again 4 data samples. So accordingly the values are here, and I can get the different I can get the histogram of the estimate of the weight attribute. If I click on OK, I get the density attribute of weight, and it is the skewed value, which is not exactly at the center. The mean is not exactly at the center, so it is a skewed attribute that I can see, and beyond that it is a Gaussian distribution I can find out from the density attribute. I can also find out draw the box plot for the weight attribute. If limit, this is a lower quartile, this is median or the second quartile, this is a third quartile or upper quartile, this is the upper limit, and beyond upper limit there is one value which I am finding. This is called as a outlier. So all box plots together also I can plot, like I can take all the box plots together of 2 or more attributes, like for temperature, height and weight. I just have to hold control key and click on OK. So all the box plots have been plotted individually on the same graph. I can also have the quantile comparison plot, maybe for weight attribute if I do. So you can see this is a quantile comparison plot. Then I can have a bar graph. When I am plotting the bar graph, I can see for the company the bar graph is like this. As we have seen that the company, the equal number of people were saying the company is good and company is bad. So the bar graph is 7 and 7. I can also plot the pie chart for it. Maybe for a company only, I try here plotting the bar chart. So it's a pie chart. So you can see again 50% people are saying company is good and 50% people are saying the company is bad. So that you can see here the values. because how to verify it, you can see in the summaries of count, frequency distribution. And for the company, if I check the frequency distribution for the company, you can see that 7 people are saying it's good and bad. So the percentage is 50 and 50%. So this is my pie chart where 50 and 50% people are saying good and bad. Or I can see the same thing for summaries, frequency distribution, but for gender. So for gender also it is equally. So if I plot the graph for gender pie chart, it will remain same. It will remain same. Only here it will be M and F instead of good and bad. We can have univariate visualization as well as we can have univariate statistics using R commander. Thus, preparing this video. Thank you.